Welcome to EDAB video number 8, Data Analysis and Business Intelligence Made Easy with Excel Power Tools. And in this video, we get to deal with big data. We're going to import 7 million rows of data from an SQL database using Power Query, and we'll load it to the amazing Power Pivot. And for the first time in this class, we'll get to build DAX formulas to use in our pivot table reports. Now, in last video, we had data that came from an Excel sheet, and we used the amazing relationship button in the data ribbon tab, which imported the data into the Power Pivot data model and automatically created these relationships for us. Then we created our reports. But in this video, our data is not coming from Excel. It's coming from an SQL database. We'll use this connector database from SQL Server Database in Power Query, and we'll load it to Excel Power Pivot's data model. Now, that data model has a number of components. And behind the scenes, there's something called a Columnar database, which can take big data and allows compression of that big data. For example, we'll import 7 million rows of data into Excel, and the file size will only be 25 megabytes. Now, step 1 in data modeling in Power Pivot is loading the data to the Columnar database. But then we create relationships, and we'll do this manually inside of Power Pivot. Then to make the reporting experience more friendly, we'll hide columns that we do not need in the reporting area. Then we'll create our explicit DAX measures to use in our pivot tables. After all the data modeling is done, then we can create our useful information reports and visualizations. That means we're going to be building a data model pivot table and a data model pivot chart. You can download all the files and follow along with the video. The zip folder, once you download it, right-click Extract All. Now, here are all the files that you can download. There's the start file we'll use throughout the video. There's notes, a summarization in PDF form, and even a few homework problems for you to practice after watching the video. Now, here are the topics we're going to cover in this video, but be sure to look below each video. Now, this is Excel Basics 1, but below our video, if you look for that Show More button and click, there's a time hyperlink, Table of Contents. If you like what you see, click that subscribe button and the bell icon. Now, anytime we're using Power Pivot and DAX and relationships, we want to make sure and use the correct terminology. We're using a data model pivot table. It works differently than a standard pivot table. And how is that good? Well, because we can create our reports from 7 million rows and create our own relationships and custom formulas. Now, the reason that Microsoft named this amazing tool that has Columnar database, relationships, and DAX formulas, the reason they named it Power Pivot, because in the end result, we're using a pivot table. So they wanted to take the standard amazing pivot table user interface and add 3 things: big data, Columnar database, relationships, replace VLOOKUP, DAX formulas, more varied calculations, and number formatting. So when you hear the name Power Pivot, that pivot means the pivot table user interface. That power means big data, relationships, and DAX. Now, what are the differences between a standard pivot table and a data model pivot table? Well, data source, of course, we're coming from an Excel sheet or connect to external when we do standard. For a data model pivot table, of course, it's coming from the data model. Reason to use data model: the data model offers more sophistication, multiple tables, relationships, and DAX. The calculations: well, summarize values by, show values as, and calculated field or item. Those are all in a standard pivot table. Data model: well, yeah, we could do summarize values by, but as we saw last video, that'll create an implicit measure, and that has some drawbacks. You can do show values as in a data model pivot table, but DAX, that's the real power. DAX formulas have many more options than a standard pivot table. Number formatting: well, let's just cut to the chase. You can't add number formatting to a formula in a standard pivot table, But a DAX formula, you just attach the number formatting to the formula. You will spend less time formatting. Can we reuse formulas? Not in a standard pivot table. You betcha. In a data model pivot table, you can use that DAX formula over and over. Data size? Well, we're limited to 1 million rows in the Excel sheet. In a data model pivot table with that amazing Columnar database, we can have millions up to even 1 billion rows of data. So data model just can hold more data. Multiple tables, not in a standard pivot table. Of course, in a data model pivot table. So the advantage, we can work from multiple tables. Relationships, not in a standard pivot table, but yeah, in a data model pivot table, we of course can use relationships. We don't have to use as many VLOOKUP functions. That's an advantage to the data model. File size. If you have data in the sheet and you make a standard pivot table, the file size will be bigger. If you have that same data loaded directly into the data model and build a data model pivot table, file size is much smaller. So when you want that smaller file size, the data model is the way to go. Now, as an example that DAX formulas have many more options than a standard pivot table, let's go over to the sheet average daily revenue. This sales transaction table has 11,000 rows of records. If our goal is to calculate the average line item transactional sales amount for each month, we can do that. We take our data, put it into a standard pivot table, and our aggregate calculation will be the average function. But if our goal is to calculate the average daily sales amount for each month, we can't do that directly inside a standard pivot table. We'd have to take this data and create an intermediate table that calculates the daily totals. Then from this intermediate table, we could create a standard pivot table where we use the calculation average. So we could use a standard pivot table, but we have to create an intermediate step. If we use DAX, we simply use a formula like this, and it has no problem from a transactional table and a date dimension or date lookup table calculating the average daily revenue. Now, we'll see this formula later in the video. Now, from the PDF notes, I think of when to switch from a standard pivot table over to a data model pivot table when any of these occur. We have more than one table, data model. More than about 50,000 rows of data, data model pivot table. Or we want DAX formulas because we could make more varied calculations. And although this seems simple, we can attach number formatting to a formula. Now, lots of you who have created pivot tables know if we use a sales column over and over every single time, we have to add number formatting, not with DAX. And of course, we can use whatever formula we create with DAX over and over. Now, what is an SQL database? Well, last video we saw an Access database, and it's similar. An SQL database is a relational database. That means there's relationships between tables that uses SQL code, that stands for Structured Query Language, to either query or communicate with the database. Now, the database we're going to be getting tables from is called Boomerangs. It's actually stored on an Amazon server. That's the server name. And there's our username and password. Now, if we were to go look at the tables, they look similar to tables we used a few videos ago: date, website, product quantity, revenue discount, net standard cost, and country code. And we have two lookup tables or dimension tables, product and country. But we're over here in Excel, and Power Query can easily connect to an SQL database and extract tables. We go up to Data, over to Get and Transform, Get Data from Database, and there it is. The first option, from SQL Server Database. Click. We have to enter the server and the database name. Now I click OK. Now we want database. We have to enter username and password. And the password has a capital E, X-C-E-L, capital I, little s, capital F, little un, and an exclamation point. And we can select either the server or the database. We're going to select the database. Now we can connect. Now we don't need an encrypted connection, so I'm going to click OK. And just like when we connected to an Access database, we have a set of tables that we can choose to import. I'm going to select multiple items. We want D country, D product, and F transaction. Now we're going to see transform data. Click. This opens up the Power Query Editor. And here on the left, we can see all three tables. We want to check each table. These two columns are fine. And just like with our Access, in this case, this is the one side. This is the lookup table. So if we were to click right here, that's every single transaction that matches that country. We don't need this column. Right-click, remove. There's the name. There's the steps. Those are good. F transactions. We don't need transaction ID. And we don't need the last two columns here. So we'll click on date, slide over to country code. Holding Shift, I click. Right-click, remove other columns. Checking each data type and column name. Everything's looking good. We have our steps, our name. Product. Everything's looking good. Right-click, remove. Now we want to come up to Close and Load, drop down, Close and Load to. Only create a connection. Add this to the data model. Our data would not load into the sheet. Data model is the only option for us. Click OK. Now, our queries pane shows us that we used Power Query to load 1, 2, 3 different tables to the data model. We can check that by hovering. And on the left, it says Load Status, loaded to the data model. Now, we have two different buttons we can use to get to the data model. Data Ribbon tab, Data Tools, that button there, or Power Pivot Data Model. Now I'm going to click this Manage Data Model button to open up the Power Pivot for Excel window. Now down here, notice we have 5 tables. The first 2 tables are for a data model that already existed in this workbook. The tables we imported are D country, F transactions, and D product. Notice each time we click on a particular table, it tells us how many rows there are. Now up here in the View group, we're in Data View. That means we're looking at the tables. This is the F transactions table. I can pull this bar up. Below each table, this is called the Measure Grid. This is where we create our formulas called measures that we use inside the pivot table values area. Now last video, we learned how to create an implicit measure, and we showed it in the Measure Grid. We did that by Advanced Show Implicit. And in fact, we should have this on all the time in case we drag and drop a field into the pivot table. We want to see it visually here. We'll come back here later and create our first explicit measure. Over in the Measure Grid, in our data view, we can also create calculated columns, which we'll also learn how to do. Now we want to go over and look at Diagram View. And look at that icon, Tables with Relationships. So I'm going to click Diagram View. Now this is a data model that already existed inside this Excel workbook, F sales and D date. Here's our 3 tables we imported from our SQL database. So step 1 was to import these tables into the Columnar database. Step 2, we're going to build our relationships. Now this is the F transaction table. This is the many side. For this D product, not only do we want to use category and product in the pivot table row and column area, but we also want to be able to look up the price and the cost. We can do that using relationships. So here's the one side. I click and drag over to the many side. A one-to-many relationship is created. Now we did this last video using the relationship dialog box over in Excel. Either way you do it, it does the same thing. Now we have a relationship stored in our data model. Now we do the same thing for country. The one side, the primary key, I drag over to the foreign key, the many side. So we've created our relationships. The next thing we need to do in our data modeling is we actually need to create a lookup or dimension table for our date column. Over here, we can have many sales on any one particular day. But we need a lookup table that will have a first column with a unique list of every single day that's possible in the F transaction table. And then we're going to add attribute columns like year and month. Now over in a standard pivot table, we can group by date. And that grouping by date happens in the pivot table cache. In the data model, we do not want to do that. we want to explicitly create a date lookup table. And if we're going to have year and month, we add those as extra columns. Now in Power Pivot, it's easy. Let's go back over to Data View. Here's F transaction. I'm in this table. We go up to Design, and you're not going to believe it. Calendars, Date Table. We can automatically create a date table here in Power Pivot. So I click New. And look at that. It actually went through the entire F transaction table. It found the minimum date and the maximum date. And it made sure over here in Calendar that it listed exactly 1 day for every possible year over in the F transaction table. Now, the reason that it did that has to do with internally in the data model, how it makes date calculations. Now, there are a bunch of functions called time intelligence DAX functions. We'll get to see one of them called total year to date. But unless you have a date table with all the possible days, many of those functions do not work. So when we're in Power Pivot, if we're going to make calculations involving dates, we use the date table new. Now, a couple things here. We are not going to need a bunch of these columns. We're only going to use year and month. Now, we could leave these here. We could also delete. I'm going to select the first one, hold Shift, click on the last one, right-click, delete. Click Yes. And our columns are deleted. Now, when we clicked Date Table New, something else automatic happened. Now, when you're over in a standard pivot table, when you use months in a pivot table, well, it sorts perfectly from January to December. That has to do with internally inside of Excel, a custom list. But over here in the data model, there is no custom list. So how are we going to get these to sort by calendar month instead of alphabetically? Well, here's how it happens. And this automatic date table did it automatically. If we were to do it manually, we'd have to go to Home, Sort by Column, and we'd have to say, please sort this month column by month number. That's why we have to have month number, because 1 to 12 will always sort correctly from January to December. So when we say, hey, month, sort by this, we get January to December. Now, again, this was done automatically, but if you ever create a date table from scratch, you got to do this step. Click Cancel. Now, the next thing is we want to come down and rename this. I'm going to get rid of the 1 and Enter. Most date or calendar tables are either called calendar or date. All right, this is our calendar table for our 7 million rows F transaction table. Now let's go over to Diagram View. Oh, look, the calendar's over here. I'm going to move it. One side, primary key. I click and drag over to the many side, the foreign key. And there we have our one to many relationship. We can drag and drop month or year into the row or column area of a pivot table. And then the DAX measures or formulas we're about to create, we can drag those into the values area, and we'll get our calculations based on month and year. All right, so that's step 1, importing from an SQL database and creating our date table. And step 2, creating our relationships. The next step is that we want to hide some of the columns that we are not going to use over in the pivot table. For example, the only column we're going to use from dCountry is the country name. I don't even want country code to be an option over in the pivot table field list. So I right-click, Hide from Client Tool. We're not going to need retail price, holding Shift, or standard cost in our pivot table field list. We are going to use them in a calculation. So I right-click, Hide from Client Tool. When I hide from Client Tool, that just means it's not going to show up in the field list. I can still use them in calculations. Over in the date, we don't need month number. That's just for an internal calculation here. Hide from Client Tool. Now we'll come back and hide some columns here after we create our DAX formulas. But now let's go over to Data View, find our F transaction table, pull this up if you need to, and we have a choice. We can either create formulas down in the measure grid, or sometimes we want to create calculated columns. Now, actually, we already have a calculated column in our data model. If we go back over into Calendar, if I click up here, oh, look at that. In Excel, we call this a helper column. Over here, they call them calculated columns. But there's the year, there's the month, and that's weird. Over in Excel, we'd use the text function to format a date and show it as a month name. But over here, it's called format. That is a DAX function called format that does the same thing as the text function over in Excel. So now back over to F transactions. Now we want to build our first DAX formulas. There are two types of DAX formulas, measures and calculated columns. Measures will build down in the measure grid, like total revenue, and use those in the pivot table values area. And the second type of DAX formula, a calculated column. For example, calculating line item revenue, or back in our calendar table when we created an attribute column. Back over in F transactions. Now what we want to do now is create a calculated column to calculate line item revenue, and then we'll create a measure that adds the line item revenue to get total revenue. That measure will be used in the pivot table. That's a two-step process. Calculated column, then use a measure to add the results from that calculated column. The second way to accomplish something like total revenue is to go straight to a measure. That means we can do both steps. Calculate line item revenue, iterating over this entire table, inside the measure, and then add all those results. So we'll look at the two-step process first. Now, how do we calculate revenue for this particular data set? Well, we have the quantity, and you can actually scroll down. This is not a data set. This is a preview of what is in the Columnar database. But you can scroll down, and you see there's lots of records where we have different units. There's also a revenue discount. What we're missing in this table to calculate our line item revenue is over in D product. We need to get retail price. Now, this is a typical lookup. We have an exact match situation where we have product. Over in F transactions, we actually have the product name. So for the third part of our formula, we're going to use this as a lookup value and look up the price. Now, let's double click where it says add column. We're going to call this line revenue and enter. And in DAX, we can't create our formulas, either measures or calculated columns, in the cells here. You actually have to come up to the formula bar. Now, the very first thing we're going to learn here is how to do VLOOKUP. Now, there's no VLOOKUP function. And because there's a relationship between fact table and that D product table, the name of the lookup function is called related because there's a relationship. Now, it's much easier than VLOOKUP because the only thing we need is the actual name of the column that has the item we want to go and get and bring back to this fact table. So I can click with my mouse, or I can down arrow to D product retail price and tab. Now, how this works is simple. Because there's a relationship on the many side between product and over to product on the one side, for each row, it automatically knows to look at the product, which is our lookup value. Then because there's a relationship, it knows where the lookup table is. So the only thing we have to give it is the column that has the thing we want to go and get. So close parentheses. And let's just hit Enter and look at how cool this is in DAX. There it is, related. It's the same formula all the way down. We could scroll to see a preview, and sure enough, it got the right price for every single row. Now, there's actually a special name for how a DAX formula calculates in a table like this. It's called row context, and it's similar to the way the Excel table feature works in Excel. For each row, it automatically can see any of these items. All right, let's continue our formula. That's the price times the units. Now, watch this. I can actually click on quantity, which is our number of units. And in earlier versions of Power Pivot, it just put the column name in. That is incorrect. Anytime you refer to a full column from any table, you have to put the table name and then in square brackets, the field name. You can see D product, that's the table name. Square brackets, that's the column or field name. So that's the syntax and the convention for referring to columns. Now, if I hit Enter here, this will give me the full revenue. units times price without the revenue discount. So we need to use this column. So I come up to the formula bar, times. This is the amount taken away. For example, 17.1 pennies in discount for every $1. So we have to use in parentheses 1 minus the revenue discount. Close parentheses and enter. Now if we scroll down a bit, ooh, there's lots of extraneous decimals, and we're going to add all of these results down in a measure, so we want to round. And luckily, it's the same name as the Excel function. I come to the end, comma, 2, close parentheses, and enter. And there we can see everything is rounded. So that's a calculated column. It iterates for every single row using row context to get whatever elements it needs from that particular row, and makes all the calculations for line revenue. Now let's come down and create our first measure. We want to add that column. Now watch what happens when I start typing the name. It shoots me up to the formula bar. Total revenue without a space, colon, equal sign. Whoa, that's different than our calculated column. The calculated column only used an equal sign. But in Power Pivot, when you create a measure, you have to put a colon and an equal sign before you type the formula. Sum. And then we want line revenue. Close parentheses. Now it's important, the colon equal sign, everything to the left, that's the name of the measure. That's what will show up in the pivot table field list. Everything to the right, that's our formula. I'm going to hit enter. There's our answer. I'm going to come up, and in the formatting group, I'm going to select some number formatting. I'm going to select United States. That number formatting follows the formula around. So when I drag total revenue from the pivot table field list into the values area, it will be formatted. Now, before we create a pivot table and see how magic measures can be, let's create our second method. That is one formula that does both steps in a single measure. Now, there's a couple things that make what we're about to do totally amazing. Now, in Excel, it's almost always more efficient to create a helper column like this and then use the sum function. However, we could simulate the helper column inside a formula, but that would be an array formula. And array formulas are calculation intensive. They take a long time to calculate. But in DAX, they created a method that we can use that is not only fast, but it works on big data. Now think about what we did here. We iterated row by row over the F transaction table. So in our measure that we're going to create to simulate both steps, we're going to need the table to iterate over, and we're going to need the exact same formula that we just created. So watch this. I'm going to cheat. I'm going to come up to the formula bar and copy everything except for the equal sign. Control-C, escape. And we're iterating. And then what did we do? We summed. So the name of the function that simulates both steps is SUMX. The sum is because we're adding. The X is because we're iterating. So I type the name, colon, equal sign, and here's this amazing function, SUMX. And look at that. It just needs a table and an expression. Now, expression is a synonym for formula. But remember what we did over here. We had a table. We had a formula. So in the first argument of SUMX, F transaction, that's the table, comma. And in expressions, that's our formula, Control-V. Now, SUMX, well, it will take this formula, iterate down every row, calculate all 7 million intermediate values, and then the sum is the aggregate calculation. There are other iterator functions, for example, average X. The only difference is it'll take those values and average. So that is our epic iterator, which is like an array formula over in Excel, but when I hit enter, much more efficient. Now let's add our number formatting. That number formatting will follow that formula around. Now there is a difference. Calculated column, sum, that's 2 steps. When we do a calculated column, these values are stored in the underlying data model. That means when you load the Excel file for the first time, and thus the database, or you click refresh, That's when these values are calculated. Inside our SUMX, the values aren't calculated until we drag and drop this into a pivot table, or we change the conditions or criteria in the pivot table. The rule of thumb is this. We're going to be using measures rather than intermediate step calculated columns, unless you're having trouble with the measure calculating slowly in the pivot table. Think about this. If you were changing a slicer or a row area condition and the formula went really slow, that wouldn't be a good user experience. So in that case, maybe you want to store the values in a calculated column and use straight sum. Now, the great Marco Russo and Alberto Ferrari, the smartest guys I know about DAX, they said, hey, look, anything under 100 million rows, in general, you can choose whichever method you feel more comfortable with. Now, we have two measures, and we'll come back and create some more. If we go over to Diagram View, now I want to highlight from Date, hold Shift all the way to Line Revenue, right-click, Hide from Client Tool. So step 1 in data modeling, import all of our tables. Step 2, relationships. Step 3, hide the columns we don't need in report view. Step 4, create our measures. Now let's create a pivot table, and we can create a pivot table over here in the Power Pivot for Excel window by clicking this button. When we click Pivot Table, it keeps this window open, but it jumps us over to Excel. So I'm going to click Pivot Table. On a new worksheet, that's perfect. Click OK. First thing I'm going to do is name this sheet 3 Pivot Tables and Enter. Now we need to move the correct tables over to active. So D product, right-click, Show in Active. F sales and D data from the other data model, right-click, Show in Active. Right-click, Show in Active. Now when we go over to active, notice that the F transaction has a sigma. That's because we hid all of the columns and list only our measures. That's an efficient way to structure our fact table, because we really only want to pull conditions and criteria from our dimension or lookup tables. Now our first pivot table will be year down to rows. And watch this. I love this. Total revenue down to values. Look at that number formatting. Now I want to click a few rows below. Go to Insert Pivot Table or use our keyboard, Alt and V. Now notice we open Create Pivot Table dialog box from over in Excel. Because we are in an empty cell and we have something in the data model, it defaults to the data model. Click OK. Now, wait a second. I don't want to have to move these tables over again. So I would like to go hide these tables, and I'd like to hide that measure because I'm not going to use it. Alt-Tab. Over here in Diagram View, right-click, Hide from Client Tool. Right-click, Hide from Client Tool. Over here, right-click, Hide from Client Tool. Alt-Tab. I'm going to open Product. Product down to rows. My measure down to values. And it calculates, and there's that number formatting. Off to the side, Alt and V. Enter. Country down to rows. And our measure for total revenue. And there's that number formatting. Now I want to talk about how a measure is calculated. Now we just talked about calculated columns and how they use row context. A measure uses filter context. That just means that whatever conditions are in the row, column, filter, or slicer, they actually flow into the measure and filter the underlying table. Remember that F transaction table has 7 million rows. But when a condition for any particular row, Carlota, Eagle, this quad product, the beauty of how DAX measures calculate is when that condition from the row flows into the measure, it filters the fact table, 7 million rows, down to just the rows for the quad. In that way, the DAX measures are more efficient when they have to calculate on big data. We can try to visualize it this way. Here's our measure. Here's the F transaction table. When it gets to the quad row, we can see that the quad is in the product table. We can see there's a one-to-many relationship. We can see in the fact table there are many quad transactions. When the quad product filters the product table down to one row, that filter flows across the relationship. And when it hits the fact table is filtered down just to the records for quad. In that way, the measure then calculates on a much smaller table, making DAX formulas more efficient on big data. Now back here in the Power Pivot for Excel window, in the measure grid, we have 4 more measures to create. We created total revenue, but now we need total cost of goods sold. That's the expense associated with the products. Colon, equal sign, and we're going to use SUMX, and we want to iterate for every transaction over the F transaction table, comma, and we're going to type our expression out. We don't have the column for line item cost of goods sold. We're going to use round. The first thing we're going to do is look up with related, D product, and we don't want retail price. We want standard cost. Close parentheses. Multiply that, and I can click on quantity, F transaction quantity, times, and in this case, we have net standard cost. It's not the actual discount. It's the number of pennies for every dollar of cost. So I can simply multiply it by that column. Inside of number, we have our calculation. Comma 2, because we're rounding to the penny. Close parentheses. That whole round is the expression. That whole round will iterate across every row in the F transactions. But now it will be calculating line item cost of goods sold. And then, of course, the sum will add. So when I hit Enter, that's the grand overall total for cost of goods sold. We'll add our number formatting. Now we need gross profit. And guess what? We're going to use both of these measures in our third measure. Total gross profit, colon, equal sign. And I can simply click in the measure grid. And look at that. It uses the correct syntax for using measures in other measures. We use square brackets only around a measure. We do not put a table name in front of it. That's reserved for columns. Then subtract, and we click on total cost of goods sold. When I hit Enter and add some number formatting, we have our grand total gross profit. Now we would like percentage gross profit. So down below, we'll say gross profit percentage, colon, equal sign, and I need to divide. So I'm going to use the divide DAX function. The numerator, we type a square bracket, and then down arrow to get total gross profit, comma, and we need to, in the denominator, compare that to total revenue. Square bracket, and there's total revenue SUMX. Now I could type a comma and indicate what should be displayed if there's a divide by 0 error. If I leave it empty, it will show a blank. Close parentheses and Enter. Now we want to add some percentage number formatting. I'm going to decrease to show 2 decimals. Now we have 2 more measures we want to create, but let's create a pivot table that shows these calculations. I'm going to go up to Pivot Table and click. New worksheet, click OK. Now let's look at our measures. There they are, from calendar, year down to rows, month down to rows. And we want 3 measures. Total revenue, cost of goods sold, and our percentage. Alt-Tab. I'm going to change the name here. Gross profit percentage, and Enter. Alt-Tab. Now let's add a slicer. Analyze. Filter, Slicer. And I want to see year as a slicer. Click OK. Right-click. Slicer settings. Hide items with no data. Click OK. Now we'll move this. Click inside of our pivot table, and I want a chart. So Insert. We want a line chart. Click. We can move it and resize it. Right-click. Hide all field buttons. Select the legend. Control-1. Put it at the top. Now wait a second. I'm going to select percentages, and of course they are so small. They're all being plotted on this axis. And I want to plot this on the secondary axis. That is beautiful. Let's select these numbers. Come over to Series, down to Number, and we're going to use some custom number formatting. Down here in Format, $sign and a 0. And when we type comma, that's like dividing by 1,000. Comma, that's dividing by 1,000,000. Then in double quotes, I'm going to put an M. That way, when I click Add, now I can see the amounts in millions. Now, next video in Power BI Desktop, we'll see that actually this kind of formatting is automatic. We don't have to do custom number formatting like that. Now I can select 2014. 2015. That is absolutely amazing. Clear filter. One last touch. Let's come up to the top. Right-click row 1, insert. I'm going to put a title. I added a title with some formatting. Now let's turn off the grid lines. And there we have our dashboard. That is beautiful. All done on 7 million rows with DAX formulas and the data model. Now we have two more measures we want to see. Alt-Tab, and in the measure grid, we're going to calculate running total, colon, equal sign. And running total just means January to December. I want a cumulative or running total. There is a built-in function, total month to date, quarter to date, and we want year to date. And this function needs an expression. Well, we're trying to get a running total for square bracket, the total revenue SUMX. And this is one of the time intelligence functions, total year to date, that works with the date table. So you have to put the calendar date column. And then total year to date does the rest. Close parentheses and enter. I'm going to add some number formatting. And now let's click Pivot Table. From the calendar, I want year and month. Let's do total revenue, running total. And that's a running total. That means when we get to March, it actually added all revenues up to the last day in March. Alt-Tab, and the measure we want to create, average daily revenue, colon, equal sign. And instead of SUMX, we're going to use average X. And here's the cool trick. We saw average daily revenue in the Excel sheet at the beginning of the video. And we couldn't do it from a transaction table. We had to list every single daily date and then add the total. Well, all we have to do in DAX is put the right table with the right size or granularity. And the table we want is the calendar table. Because remember, the first column of that table has a unique list of all the possible dates from the fact table. So when our formula iterates, it sees all of the days, comma, and our measure, square bracket. And it's going to be our total revenue. That means that measure will iterate over that table, first day, second day, third day, calculating the total daily sales for every single day. That whole array of daily sales values will then be used in an average calculation. Close parentheses and enter. We'll add some number formatting. So that's a lot easier than the Excel example we saw at the beginning of the video. Alt-Tab. Now we can drag average daily revenue. And the beautiful thing about that measure is right here, it sees January. So it only calculated the total sales amount for every day in January. And then it calculated the average. When it got to 2014, it actually saw every single day in 2014. So the measure has the sales total for all the days in 2014, and then it calculates the average. And in the grand total cell, it actually sees every single date for all of the years, calculates the individual total sales amount, and then calculates an average. That is a pretty amazing DAX calculation. Wow, that was an epic video all about Power Pivot. We saw how to take 7 million rows from an SQL database and then use Power Query to import, clean, and transform. Then load it to the Columnar database, create a calendar table, create our relationships, hide all the columns and other elements we didn't want to see in the reporting view, and then we created our measures. And the end result? Data model pivot tables and data model pivot charts. All right, if you like that video, be sure to click that thumbs up, leave a comment, and subscribe, because there's always lots more videos to come from Excelisfun, including EDAB number 9. We'll learn how to use Power BI Desktop. All right, we'll see you next video.